Hi everybody, welcome to the Manifold channel. Today we're going to take a look at how Manifold's use of parallel technology makes it run a lot faster for many spatial operations than non-parallel software. We're going to use an example here which shows parcels in the town of Crisfield, Maryland in the United States. And in our map we have a parcels drawing layer, which is what we see here, and a Bing Maps layer which we use as a background map. We can zoom in a little bit further to see the various parcels a little bit better. The parcels have been colored in a thematic format based on their zoning. What we're looking at here is Manifold System Release 9, and this also works in Manifold Viewer, the free package you can download and try this out at home. You can download all this data, by the way, from the Manifold web pages, either from the Viewer download page or from the Manifold Release 9 download page. Now, an upper layer that we have here is called Flood Draw for flood drawing, and I'll zoom way in here closer to so we can see what this drawing is. This drawing has zillions of small polygons, and it's been created doing a computation based on a model that predicts the flood zoning. And each one of these flood zones is colored based on a flood risk number from 0 to 8, with the higher numbers being red. Our task is as follows. What we'd like to do is, you can see how all these flood zone polygons cover up some of the other polygons here. What we'd like to do is we'd like to find all regions in the map where flood zone polygons which have a flood risk greater than 6 or above intersect with one of the parcels, and then we want to cut out just that part and create a new layer so we can just show a layer of polygons in the map that show all regions where there's a flood risk of 6 or greater that intersects a real estate parcel in Crisfield, Maryland. Now you'd think, okay, that's some pretty complicated stuff, but it turns out it's actually quite easy to do. What we're going to do is we're going to use this query right here called Crisfield Clipping All Cores. I'm going to undock it and resize it a bit so we can see it without taking up the whole window. And what we're going to do is we're going to use a little bit of spatial SQL for this. Spatial SQL isn't all that complicated. We could do this in a series of steps using the transform panel. But instead we're going to use the spatial SQL here. And the operative part is right here, this little bit called thread, system CPU count, which tells it to use all 8 threads. So Manifold, as you probably know, is fully automatically CPU parallel. When you write SQL here, you don't have to know anything about parallel software, just write the same spatial SQL you always would, and Manifold will automatically parallelize it and will automatically run on as many cores as you like, as you have in your system. So what we have here is, let's turn on the resource monitor, and let's put the resource monitor down here. We can see a little bit better. And what we're going to do is we're going to select this, and then we're going to, okay, I got to select that first, then I got to bring the resource monitor back up. Sorry about that. Okay, I'll start running it, and then I'll bring the resource monitor back up. So 1, 2, 3, run. The query is now running, and as you can see, as the query runs, you'll see how all 8 cores are in use here. You can see how that is saturating each of those 8 cores 100%. In 10 seconds, 11 seconds, 12 seconds, 13 seconds, and done. As you can see, it took it about 13.5 seconds. I'm going to move this back out of the way. Let's see from the log pane exactly how long that took, the log window. And that took us 13.3 seconds. Not a bad time to do a computation this size. I'll kind of give away the game a bit. If you tried this computation in SQLite, it'll take over 3 minutes. If you did it in the PostGIS or SQL Server, it would take you about 1.5 minutes. So 13 seconds is way faster than all that. What we can do is, if we like, and what that did is it created this little table right here called Bobo. I'm going to get rid of that because now what we're going to do is we're going to rerun this same query, but instead I'm going to take away this threads statement, which thread says how many threads to use, and system CPU count returns how many CPUs there are in the system, and the CPU cores in the system. This particular system, there are 8. So I'm going to get rid of that. Just click delete, and we'll leave the semicolon where it is. And now I'm going to run this query again. It's now going to run with only 1 core because we've deliberately turned off parallelism. So let's do that again. 1, 2, 3, go. It's going to take it considerably longer now, because instead of using all the cores in the system, it's only going to use just one of the cores. And you can see how that it comes up here, and each core one at a time is being used as Windows allocates resources, because a Manifold is doing a lot of stuff here. So Windows is allocating how much resource it does. What is the actual SQL query that we're running here? Let's take a look at that. I'm going to move that out of the way, and I'll put this resource monitor back up. what we've done is the geomClip function clips two different geometries. So we're taking the geometry in the flood drawing, and we're taking the geometry in the parcels drawing, and we're clipping the one with the other. But we only want to do that and putting the result in a table called Bobo. We only want to do that from parcels in the flood table where the flood grid code is greater than 6. That means where the flood risk is greater than 6, and where this geom touches drawing says it returns true if two geoms are touching, where the geometry in this drawing is touching the geometry of the other drawing. There, it's just finished while we were talking. Let's see how long that took. We can see View, Panes, Log Window, and scroll back down. Here we can see in this case it took 61 seconds. So about 5 times as long as it took without using all the cores. Now 61 seconds is still very fast. That's still about 50% faster than it would take in PostGIS or SQL Server. That's one of the reasons because Manifold is intrinsically faster. The database engine within Manifold was designed for spatial operations, whereas SQL Server is a general purpose big DBMS, and PostGIS is running on top of PostSQL, which is PostgreSQL, which is also designed as a general purpose database. Let's see what the actual result is. I'm going to close the log window here, and here's our map window. And let's turn off the flood drawing, come back here to the parcels drawing, and let's create a drawing from this table. If we open up this table, we see that it's a bunch of geometry areas that have been created. Let's create a drawing from that. Right-click on that, choose Create, New Drawing, and I'm going to use that for geometry, create a spatial index. I'm going to leave it at a pseudo-Mercator, create drawing. And now what I'll do is I drag and drop that drawing into here, and we can see there's a bunch of different areas that have been created. If I zoom in closer, we can see what they are, like that. And these are all the flood risk areas greater than 6 clipped out of the parcels in which they touch. Let's style that with different coloring. So we'll use, let's use this bright color right here. It's nice and bright. And I also want to style the borders so the borders don't turn black when we zoom out. And let's style the area border color like that as well. And we can now see all the spots in Crisfield, Maryland, where the high flood risk zones overlay various parcels. I want to emphasize that parallel stuff is really cool, but as you can see, the difference between running 1 core and running 8 cores is not like 8 to 1. It's about 5 to 1. That's because there is some overhead involved in what it's doing, and so even though it uses all cores 100%, as we saw in that performance monitor display, it's still not quite as 1 to 1 as running 8 cores. You get to 8 times faster. If we had 16 cores, it wouldn't be 16 times faster. It would only be about 12 times faster. But that's still pretty cool. The net result is we're still doing something in 13 seconds. That would take, what, about 50 times longer in SQLite, or about, let's see, what's that work out to? About 10 times longer, or 15 times longer in either SQL Server or PostGIS. When you multiply these out to much larger data sets, things that instead of taking 13 seconds in Manifold would take a Manifold in Manifold, you're now talking things that would take an hour or hours in a SQL Server or PostGIS. So there's a lot of time to be saved, and all that is time, which is your time that you save when instead of looking at the screen waiting for something to finish in hours, it's finished in seconds or a minute or so. I hope you've enjoyed this demonstration. Remember, Manifold is automatically parallel. You don't have to know any SQL at all to do this stuff, or any parallel programming at all to do this stuff. You just write the same SQL. They use the same standard transforms that you'd use in any setting, and without knowing anything at all about parallel software. And Manifold will automatically parallelize it. And for things like kriging and other sorts of applications where Manifold can use GPU parallelism as well. If you have a GPU in your system, and it makes sense to use that GPU, Manifold can use thousands of cores automatically, massively parallel, for really, truly intense speedups. Like I say, you can download this data set as shapefiles, try it out in your own GIS, see how fast it runs. Rerun this demonstration yourself. You can download this project, download Manifold, the free Manifold Viewer, open up the project, run it in Viewer. Viewer requires no registration. It never times out. There's no nag word. There's no advertising. There's no begging for donations. It does all this stuff perfectly for free. So you can try it out on your own system at home and see how much faster parallel technology is. Turn the parallelism on and off to see for yourself. I hope you've enjoyed this video. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.